Okay, back with another example involving u substitution. You see here we have 3e to the 3x. We're charged with finding the antiderivative. So again, we're looking for our inner function to match up with u. The inner function is going to be our exponent, because we know that if we have e to a variable and we're trying to take the antiderivative, whether it's e to the x or e to the u or e to the whatever, that's a very quick and simple antiderivative to take. We don't have that right now. We have e to something ugly. We have e to the 3x. 3x is our inner function. That's our ugly, if you will. So let's make u equal to that 3x. All right, so here we go. U is equal to 3x. Okay, and what does that allow us to do? Well, it allows us down here to have e to the u by substitution, because u is 3x. 3x was in the exponent, so now u is in the exponent. But again, like I mentioned in the previous video, we need a du down here. Okay, we can't have dx down here because the x's and the u's, I think Bloods and Crips, they don't work together. Okay, so what do? We take the derivative of u with respect to x. All right, so what is our du? Well, what's the derivative of 3x? It's a nice easy derivative to do. We know that that's equal to 3, and then the dx moves over to the right again. Okay, so u says, I'm coming into the integrand, but I need du to come with me. And du says, okay, I will come into the integrand as well, but I have to sub in for a 3dx. Is there a 3dx? Hey, look at that. What a coincidence. There is a 3dx. We've got the 3 right here, and we've got the dx right here. So those two are going to match up, and they're going to leave the integrand because they're equal to du. That allows du to come in. And we now have e to the u du. Okay, so it's by substitution. 3x is subbed out, and u is subbed in. 3 and dx are subbed out, and du is subbed in. What does that leave us with? It leaves us with the antiderivative of e to the u du, a basic antiderivative which we can get extremely quickly because we know that e to the x or e to the u antiderives to itself plus c. So what do we have here? We have e to the u plus c. Okay, that is our antiderivative. But once again, just like the previous example, we don't want our answer in terms of u. We want it in terms of x. So we have to back sub in. And we know that u is equal to 3x, so therefore our final answer is e to the 3x plus c. This is our general antiderivative of 3e to the 3x. Okay, how do we know that? Once again, let's quickly check our answer. All right, g of x is equal to e to the 3x plus c. That's our answer. Okay, and we want g prime of x. All right, if we derive this function, we should get our initial function that we were looking to take the antiderivative of. Well, what do we have here for g? G is e to the ugly. Chain rule. Chain rule with e to a function other than x is going to be e to the ugly derives to e to the ugly times the derivative of the ugly part. And the derivative of 3x is 3. Plus c, well, we know that constant always derives to 0, so that's it. E to the 3x times 3. That's exactly what we have right there. So this answer checks out. We have our antiderivative, e to the 3x plus c, and we used u substitution.